Hello, I'm Dr. Harper. This video is in Supply Chain Analytics. It's a Logistics Homework Excel tutorial, Company A, Part 2. So let's bring up the problem. Now in this problem, it is Part 2 and it is an extension to Part 1. Company A is planning a cargo shipment of agricultural commodities from Los Angeles to Shanghai. The cargo ship has 3 cargo holds where only one type of commodity can be placed in the same cargo hold. However, because of balance considerations, weight restrictions for the cargo holds are required. The following information was obtained. Now, this information as far as the amount shipped, cost per ton, profit per ton, maximum weight allowed per cargo hold, and relative weight restrictions, all of this is identical to Part 1. The only difference to Part 2 is this sentence right here. The cargo ship has 3 cargo holds where only one type of commodity can be placed in the same cargo hold. Let me bold that and underline that. That's the only difference between Part 2 and Part 1. So you can't have more than one commodity in a hold. You can only have one per hold, and that's all. You can't mix them. Okay, so since this is an extension to Part 1, let's bring up Part 1. And here's Part 1. And so let's work it. So first of all, this is Part 1. And if you recall, just let's bring up Solver here. Here's Data, Solver. Just to refresh your memory, let's reset everything. Refresh your memory here. Let's do this again. Where the objective function is, well, actually, let's close this out. Let's zero this out. Let's just solve this again. Solver, quickly. So the objective function is the total profit. We want to maximize it by changing these values here. There they are. We're going to add. Well, everything that you ship, it has to be less than or equal to the to be shipped. You don't ship more than what's to be shipped because you don't have it to ship. Add everything that you ship here is less than or equal to the weight limit in each of the holds. And then we have the forward is less than or equal to the maximum. Add the forward hold is greater than or equal to the minimum. Add the center is less than or equal to the maximum. Add, and the center is greater than or equal to the minimum. Okay, and okay, so all of these we did before in the other video. So when we solve this thing, we solve it, and there's the 605,000. We did find a solution. Solver found a solution. All constraints and optimality conditions are satisfied. Keep it. Yes, we keep it. So we'll start here, and then from here we'll modify it. Now notice we have 1 in the forward hold. We have 1, 2, 3 in the center hold, and we have 2 commodities in the rear hold. So Part 2 says, well, you can't do that. You can only have 1 commodity per hold. Well, you have 4 commodities, so you have 3 holds, the forward, center, and rear. So 1 commodity cannot be shipped by that requirement. So let's solve this one. We're going to have the same. We'll go to Solver. Well, first of all, we have to set it up. Now, the way we set this up is we take the forward, center, and rear, and let's bring it down here. Okay. And let's have the max shipped. So here's how we'll solve this. The max shipped down here, Control C, and add it here and add it here. And so over here, let's have the commodities. Well, over here, we're going to have, again, the forward, center, and rear. Put that right here. And then we're going to have the commodities, 1, 2, 3, 4. And so we'll put it here. So right here, this right here will be binary. So let's box this in and shade this in. This will be binary. In other words, it'll either be 0 or 1. And then down here at the bottom, we'll sum this. Sum all the forward. So the sum of the forward, in other words, a binary means each one of these has to be either 0 or 1. So the sum here has to equal 1. And the sum of each one of these, the sum of this one is 1, the sum of this one is 1. And that forces only one of the commodities to be in the forward hold. But then the maximum shipped over here, we'll box this in. This is going to equal our binary times the weight limit of 1800, F4 to fix that. And here this will be equal the binary for the center cargo hold times the weight limit of 5,000. Okay, F4 to fix it. And then this will equal the binary times the weight limit on the rear hold, F4 to fix it. Okay, and so you notice what we did here. We put the weight limit times this, so that'll either be a 0 or 1. So that either, well, this is either 0 or 1, the blue, but this right here will either be 0 or 1800. Okay, and the same as here, and the same as here. And then we copy this down. So when we copy this down, and let's take this back out, no border, then put it back in. There we go. Clean it up a little bit. So the idea here is this table right here is either going to be a 0 or the weight limit maximum shipped. So our constraint will be all of these, our decision variables here, must be less than or equal to these. And these will either equal 0, but only one of them, since the sum is 1, only one of them can equal the weight limit. So let's bring back solver and let's solve this thing. So let's reset all, start from the very beginning. And so we're going to start setting everything up. First of all, we still want to maximize our profit by changing these cells, comma, and also these binary cells. Okay, add. Now our constraints. As before, everything we shipped must be less than or equal to the to be shipped. Okay, add. Everything that we ship in each hold. Now then, we're not going to have the maximum for the weight limit. Now we have all of these must be less than or equal to the maximum ship there. Okay, and then we add, and we say again, we have the weight limits. The total ship must be less than or equal to the maximum. Add, the total ship is greater than or equal to the minimum. Add, the total shipped is less than or equal to the maximum in the center hold. Add, the total ship is greater than or equal to the lower limit. Then we say OK. Okay, so now we've set up the limits. Now we have the binary. So we add the binary. All of these here are going to be binary. So we come down here and say these are going to be binary. And then we add, and all of these here are going to equal 1. Each one is equal 1. And there we go. So now when we solve this thing, solver found an integer solution within tolerance. All constraints are satisfied. Within tolerance means they iterate to it, and it's within very small significant figures. Okay, and so if we allow this to be, but it doesn't matter. Okay, so we say okay, and so now we have our shipping schedule, and notice now, let's bring the significant figures down. We don't need all these things. There they are. There we go. So we can see, well, we can see our shipping schedule right here. We can see which commodity is shipped in which hold at a total profit of 580K. Okay, so that's all I have for this problem. I hope this helps. Between the now and the next time I see you, I want to urge everyone to be safe and take care.